Welcome to AminAcademy.com. In electrical engineering, let us discuss about magnetic field strength. A magnetic field strength at any point within a magnet field is numerically equal to the force experienced by a north pole of 1 Weber placed at that point. Hence, unit of Weber is Newton per Weber. A magnetic field strength is a measure of the intensity of a magnetic field in a given area of that field, represented by H. Magnetic field strength is typically measured in amperes per meter. Also, it's equal to Newton per Weber as defined by the International System of Unit, that is SI units. Now, we'll discuss further here that here F equal, that is force, equal m into 1 over 4 pi epsilon 4 pi mu 0 r squared. Then H equal m over 4 pi mu 0 r cube, or which is equal to ampere per meter. Next, we'll discuss about magnetic potential. A scalar quantity characteristics of a point in a magnetic field whose negative gradient equals the intensity or strength of the magnetic field and which represents the work required to bring a unit north pole from a point infinitely remote up to the point in question. That means from infinity distance to the north pole. That means we have to bring down a charge from infinity to the north point. It is called a magnetic potential. Here, a magnetic potential at any point within a magnetic field is measured by the work done in shifting a north pole of 1 Weber from infinity to that point against the force of the magnetic field. It's given by magnetic potential M equal m over 4 pi mu 0 r. The unit is joules per Weber, work done per Weber. It's a scalar quantity. Next, flux per unit pole. A flux per pole is an important parameter of a DC machine which represents the amount of magnetic flux passing through each pole of the machine. It is usually measured in Webers or Tesla meter square. The unit is Weber or Tesla meter square. Here we can write the formula for this. Phi equal m Webers. Next, magnetic flux intensity. Magnetic flux density. A magnetic flux density B is defined as the force acting per unit current per unit length of an wire placed at right angles to the magnetic field. That means force acting per unit current per unit length of an wire. It is vector quantity, means direction is considered. Magnetic flux denoted by B. The SI units of is Tesla or kgs minus 2 a power minus 1. Mathematically, this can be represented by B equal to Phil, FIL, where F is the force, L is the wire length, F is the total force acting, and I is the current flowing. B equal to Phil. Here, that magnetic flux density is high at center and going less away the center of the cable. Now, these are the small definitions about some important point on magnetic field strength and magnetic potential and flux per unit pole, as well magnetic flux density. Further definitions are there. We will discuss in next videos. We have done. Please subscribe our YouTube channel.